I will study dual simplex method. In this dual simplex method, the minimum ratio column will not be there. Instead of minimum ratio column, this xb is used for selecting leaving vector. We'll explain in the problem. First step, it should be have maximization type, and all the constraints should be less than equal to sign, and RHS considered for selecting leaving vector, and most negative element from the xb or RHS will give the leaving vector. Entering vector is calculated depending upon leaving vector. Now delta j will be calculated as usual. After calculating delta j, one more I have to calculate in the row ratio. After calculating delta j, we have to calculate ratio. That ratio is nothing but delta j divided by entering vector values, corresponding values. Next, from the ratio, we have to select the least negative element. Least negative element for entering vector. And the rest of the procedure is same as that of simplex method. Only the variation is from xb we are calculating, or from xp we are selecting leaving vector. From ratio we are selecting entering vector. From xb we are selecting most negative element. From ratio we are selecting least negative element. This is the very important part of dual simplex method. And first problem, I will explain this problem. Minimization of z is equal to 3x1 plus x2 plus x2 greater than equal to 1, 2x1 plus 3x2 greater than equal to 2, x1 comma x2 greater than equal to 0. This is a given problem. Now it is a minimization, and this minimization is converted into maximization by multiplying minus 1 on both the sides. That is minus 3x1 minus x2. Right. Now x1 plus x2 greater than equal to 0, sign will also be changed by multiplying minus 1 on both the sides. Minus x1 minus x2 less than equal to minus 1. Minus 2x1 minus 3x2 less than equal to minus 2. This is the conversion. This is the standard procedure. After converting all those, we have to convert these inequalities or constraints into equation by removing this less than equal to sign. It is a less than equal to sign. Because of that, we are adding slack variable. Same procedure as simplex method. Less than equal to signs are there. We are adding s1 and s2, and these coefficients are 0 s1 and 0 s2 in its objective function. Now this objective function and constraint by all considering all these constraints and objective function are formulated in the table. You know this how to form the table. Basic variables are nothing but s1 and s2. CBVs are nothing but coefficient of basic variable, and x1, x2 and s1, s2 are the variables. These x1, x2, s1, s2 are having C's. C's are nothing but minus 3, minus 1, 0 and 0. Right, minus 3, minus 1, 0 and 0. Now, this is the first constraint. Second constraint, xb is inserted at the end of the table. In all other problems, what we are doing, CBV along with xb we are writing. Now, we have to write xb at the end of the table because we are calculating leaving vector from xb. Now, xb is having minus 1 and minus 2. Most negative element means minus 2. Minus 2 is considered as leaving vector. Minus 2 is considered as leaving vector. Depending upon xb values, most negative element is selected, which gives the leaving vector. Now, to calculate the delta j, you know how to calculate delta j, CBV into xj minus cj. Now, 0 into this, 0 into this, zeros, minus of minus 3 is plus 3. Like that, 0 into 1, 0, plus 0 into minus 3, 0, minus of minus 1 is plus 1. Like that, delta z is calculated. After calculating delta j, you have to calculate ratio. Here, ratio is calculated depending upon delta j divided by leaving vector. Delta j divided by leaving vector means 3 divided by minus 2, 1 divided by minus 3. 3 divided by minus 2, 1 divided by minus 3, 0 by 0, 0 by 1 is 0. Now, minus 3 by 2 is nothing but 1.5, minus 1.5. 1 by 3 is nothing but 0.333. So because of that, comparing these two negative values, least negative element is 0.33. This least negative element is selected for entering vector. This least negative element is selected for entering vector. Least negative element is selected for entering vector. Now, intersection of these two, most negative element, least negative element is nothing but leaving vector and entering vector is minus 3. It should not be minus 3, it should be equal to 1. To make this equal to 1, again minus 3 will be divided by minus 3, right? Minus 3 divided by minus 3, which will become plus 3. So minus 3 will be divided for whole row from x1 to xb. Till this we have to divide. Now minus 2 by 3, minus 2 by 3, minus 3 by minus 3, right? 0 by 3, minus 1 by 3. Like that, we have to convert. R2 has been replaced here. R1 will be here. Now for R1, we have to write the equation. For R1, minus 1 is there, right? Plus 1, 0. R1 plus R2. This is R1, this is your R2. So make this 0. Like that, R1 plus R2 we have to apply for minus 1, minus 1, 180. For these 4, I have already written right side of your table. You can go through that. So we'll get this table, right? Once again, after getting, we have to apply for xb row column also. In this, again we have to compare. This is a plus value. You should not consider this. Most negative element is minus 1 by 3. That is 0.333. That will be entering vector, leaving vector, right? That will use leaving vector. Now, considering this leaving vector, once again we have to calculate R value, that is entering vector. Now delta Z will be calculated as usual by formula. Now R, that is ratio, is calculated by delta Z by leaving vector. 7 by 3 divided by minus 1 by 3. 3 will cancel each other, we will get minus 7. Right. Next 0 by 0. Next 0 by 1. Next 1 by 3 to minus 1 by 3. That is minus 1. From minus 7 and minus 1, least negative element is this minus 1. That is your entering vector. Entering vector means S2 is entering here. Intersection of entering and leaving gives the key element. The key element should be always equal to 1. So now it is a minus 1 by 3. Now to convert this into 1 plus 1 minus 1 by 3 multiply or multiply by minus 3. So 3 will cancel each other. We will get 1. So that will be written right side. You can go through that. Now after converting all the values, we will get delta Z as this, and right hand side, that is xb values are positive in third iteration. That means RHS values, when it becomes positive, it shows that the problem has been solved. When RHS are positive, because from RHS or XB we are calculating or we are considering most negative element. Here we are calculating or considering most negative element. Now here it is positive. Because of that, the problem completed. If there is no entering vector, leaving vector, then we should not get any entering vector. Because of that, problem ends here, and the value of x2 and x2 will get only x2 value we have to consider, that is 1. That value, and x1 will be considered as 0. x2 equal to 1. When you put this equation in the given problem, we will get minimization of z is equal to 1. This is how you have to solve the dual simplex method. Only you have to consider xb for most negative element, and that is the leaving vector, and from ratio you have to consider entering vector by considering least negative element. This is very important. Hence I calculated minimization of z. These are some assignment problems for practice. Just go through these problems. Thank you.